Good morning, y'all. Today is going to be lesson 5.6. I know Christmas is right around the corner, but we have a couple lessons left to go. So today we're going to focus on ways to show a quadrilateral is a parallelogram. The first way says, if both pairs of opposite sides of a quadrilateral are parallel, then the quadrilateral is a parallelogram. So in a picture, if we look at it, if we have a parallelogram, if you know both pairs of opposite sides are parallel, it's going to be a parallelogram. Number two, if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So in this picture, you'd have the parallelogram. These two sides are congruent. These two sides are congruent. Then you know it's a parallelogram. Reason 3, if one pair of opposite sides of a quadrilateral are both parallel and congruent, then the quadrilateral is a parallelogram. So it says a pair is both parallel and congruent, or it could be these two sides parallel and congruent. It doesn't really matter which set it is, but it has to be one set, the same set, parallel and congruent, then you have a parallelogram. Number 4, if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So we have the parallelogram, we have the diagonals this time. If you know that these two pieces are congruent and these two pieces are congruent, then you have a parallelogram. And last but not least, if both pairs of opposite angles of a quadrilateral are congruent, then you have a parallelogram. So if this angle and this angle are congruent, and here are congruent, you have a parallelogram once again. So these are the 5 reasons. Both sets parallel, both sets congruent, one set parallel and congruent, diagonals bisecting each other, or opposite angles being congruent. Question 1 asks, what is true from the definition of a parallelogram? Well, if we remember our wonderful story the other day, and we look at one of our rules, you knew that both pairs of opposite sides are parallel. We knew that both pairs of opposite sides are congruent. We knew that both pairs of opposite angles are congruent. We knew that the diagonals bisected each other. So from the definition, you can see that is the way you're going to be able to prove that it is a parallelogram, because you know that a rhombus, rectangle, and square are all parallelograms in that family. Let's look at the first one. We're going to prove it the long way. So we're going to prove that this is a parallelogram. So we're going to need to draw something in. We'll draw in the reflexive side. We can see that these two triangles, top and bottom, are going to be congruent to each other. So we can prove the top triangle and the bottom triangle by side, side, side from the given information. So we had AB was congruent to CD. We had BC congruent to AD. And we draw in AC, which then AC was congruent to AC. This gave us triangles ABC congruent to triangles CBA. Our goal is to get that it's a parallelogram. Well, if you think about parallelogram, both sides both pairs of opposite sides have to be parallel. So we got to get this idea of parallel. Parallel comes from where? Comes from angles. Angles come from where CP/CTC is created. So we have CP/CTC next. Let's say we take this angle and this angle, call them 1 and 2. Angle 1 is congruent to angle 2, which then would give me BC parallel to AD. There's 1. We also know from CP/CTC that we'll call this angle 3 and angle 4. Angle 3 is congruent to angle 4, which by the same reason gave us CD parallel to AB, which then makes ABCD a parallelogram. Wow, a lot of work going on in this proof the long way. So the first one is 2 points make a line. 2 was the reflexive. 3 was side, side, side for CP/CTC. 5 was, let's see what kind of angles are 1 and 2. They're alternating and they're in between the parallel lines. So it says if alt interior angles congruent, parallel. And then 6 would be if both pairs of opposite sides parallel, then parallelogram. So you notice that you can take the given information and you can prove it the long way because they all come back to that both pairs of opposite sides are going to be a parallelogram, and you know that by definition. You can see that. That's why the word parallelogram came from. The shorter way to do this would have been that AB was congruent to CD and BC would be congruent to AD. These two are something that I'm looking for. If I find these two things, I know that ABCD would be a parallelogram. And the reason is it'll never, ever, ever be definition of parallelogram. So please don't use it. Describe what is going on. So what's here, it's both pairs, opposite sides, congruent, then we had the parallelogram. So make sure you're specific with what rule you are using out of the 5. Okay, just don't tell me definition of parallelogram. If you do, you will get it wrong because none of them are definition of parallelogram. Number 3, instead of doing it the long way, let's see if we can do it the short way. These two are parallel, and then the same two are congruent. We learned that up on top there, if one set is both parallel and congruent, we know it's a parallelogram. So the shortcut for this would be that these are parallel, these are congruent, giving me A, B, C, D is a parallelogram. Reason, and it's not definition of parallelogram, we just discussed that. If one set is parallel and congruent, then parallelogram. 4, which is the most least used, to be honest, the diagonals bisecting. You can see that once again we were given that both sets of opposite sides end up being diagonals bisecting each other. So we can go right into what we need to find, giving us A, B, C, D is a parallelogram. This one, if both pairs of diagonals bisect each other, parallelogram. I know they're kind of long-winded, but everybody's is going to be different. Make sure you just get all the information you need. And last but not least, this one is kind of more of a postulate than a theorem. We have to treat it as such, remembering that a theorem has been proven. A postulate is an unproven statement. A and C are congruent, B and D are congruent. We learned that opposite angles in a parallelogram are congruent. So if A is congruent to C and B is congruent to D, we have a parallelogram. Reason one, both pairs of opposite angles are congruent, then parallelogram. So your goal when you're proving these, yours aren't going to be that quick. None of them are really one step. So instead of doing them the long way, your goal is to look for these ways. Look for both sets of opposite sides being congruent. Look for both sets being parallel. Look for one set being parallel and congruent. Look for the diagonals bisecting each other. Look for opposite angles being congruent. This one and this one are probably the most common ones that we use and know. So the rest of the time, I would like you to work on worksheet 5.6. It goes through filling in answers, and there's a couple proofs on your own, and there's a couple questions from the book. Good luck to you, and I will see you tomorrow.